Okay, so trigonometry. So we're going to start talking about trigonometry, just learning some of the vocabulary and just some of the basics, okay? Um, when we're talking about a vector, okay, we use vectors to represent motion. If you take physics, you'll work with vectors, right? So if we have a vector with an initial side, like this one is, right, and we rotate that vector, wherever it ends is what we call our terminal side. Okay, so pretty straightforward, right? So the initial side is the starting position, and the terminal side is the position after the rotation. So this point right here, this is called the vertex. It's the end point of the vector or the ray. A vector is a ray. Okay. Trigonometry is one of those subjects that is extremely applicable, especially when it comes to describing motion and direction. So, for instance, okay, where would we use trigonometry? Well, trigonometry is used if we're talking about a projectile, or could be a bullet, right? The trajectory of the bullet. Okay, that's trigonometry. We use trigonometry when we're looking at that, because if we look at the trajectory of a bullet, it has a horizontal component and it has a vertical component. Okay, if we're looking at maybe a cannon firing something, or maybe Jalen Hurts throwing a 50-yard pass, right? That's a projectile. It has trigonometric components. A projectile has a horizontal component and a vertical component. If you're talking about a soccer ball, a baseball, all of this is trigonometry. The path that a plane is taking, or the bearing that an airplane is taking, that's trigonometry. So trigonometry is extremely applicable to our real world, just like logarithms are. Whereas we see logarithms more in science like chemistry and biology, or maybe even forensics, you're going to see trigonometry more in the physical space. Okay. Yes. Forensic is the science that's used, like, I don't know the actual definition, but like when you're trying to figure out what happened at a crime scene, that's forensics. You're taking the data and you're examining the data. Okay. To this? Yep. Okay. Okay. Let's see. When we're talking about our sides rotating, right? So if we start with our initial side like this, we rotate counterclockwise, right? So the positive angles are counterclockwise. So like this one might be, maybe this looks like maybe it's 120 degrees. Positive degree, I'm rotating, basically it's like you rotate up, right? It's counterclockwise. So of course, the negative angles are determined by a clockwise rotation. So if I were to start at this initial position, if I were to rotate clockwise, so go this way, this would be negative 240 degrees. So the negative angles go clockwise. And that's very important to know that direction. It makes a difference. Yes.
So how do you know which one to look for, or do you just look for both of them?
What do you mean look for?
Like the positive angle and the negative angle. Like which one do you work with?
It depends on the scenario, but usually it's the positive angle. You can use either. They're what we call coterminal angles. Right? They're called coterminal angles. So 120 degrees is equivalent to negative 240 degrees. Okay, they're coterminal. Usually we work with the positive angle, but we need to know that they're equivalent. So 100 degrees would be equivalent to negative 260 degrees. Okay. 90 degrees is equivalent to negative 270. What do you notice? They add up to 360. 360, which makes that full circle. Okay. And we'll talk more about that later. Okay, yes.
So the positive angle is where the red arrow was?
The positive angle moves counterclockwise.
Yeah, so that's like inside of that is the positive angle.
Yes, yeah. So inside here, exactly. Right? And the angle is measured from the initial side, and the initial side is always going to be that positive x axis. That's the initial side. So starting there, there's no motion, okay? Starting right there is like, okay, we're ready to start. And then we rotate clockwise and end up at our terminal side, okay? At least I should say for now, our initial side will be the positive x-axis. Okay. So if I want to draw a 220 degree angle, okay, 220 degree angle. So here's my initial side. Why did it do that? Let's try that again. Okay. Here's my initial side right here. Okay. And then we rotate clockwise or counterclockwise 220 degrees. Well, here's 90 degrees. This is 180 degrees. Right? This is 180 degrees. This was 90 degrees. So 220, I have to go another 40 degrees. So just to get a good estimate, right? This is 90 degrees, right? So halfway would be 45 degrees. So I'm going to go just a little bit shy of halfway. So I'm going to put my terminal side there. That represents 220 degrees. Okay. Okay. Label an angle that is coterminal. So how else could I have gotten to that same position? Go the other way, yeah. Right? Going this direction. Well, right, that's a full circle. So if I did 360 minus 220, that is 140 degrees. So if I went 140 degrees that way, that would be negative 140 degrees. Okay? That little symbol there, that's called theta. That's a very common Greek letter that we use for angles. Theta. You can use any variable you want on the calculator.
Yeah, but it's one of the like 27, I think, that you can use. You can use you can use each letter, and you can use theta.
Right. And the reason is that theta is the default angle for any trigonometric functions. Okay, theta is the default angle. Sometimes you'll see alpha, sometimes you'll see beta, right? Alpha, and they always use Greek letters, right? Alpha, beta, okay. You won't see gamma, but theta is the most common. Okay, so and the reason it's called coterminal is because we end up at the same terminal side. We end up at the same terminal side. Now, there are other coterminal angles. For instance, if I went, let me just erase all this stuff here. Leave that terminal side there. Let's say that I started here and I went all the way around. How many degrees would that be? 360. And then I continued 220 degrees. I would end up at the same coterminal position, the same terminal side. So 360 plus 220, 580 degrees is another coterminal side. I could keep going. I can keep adding 360 and I get to the same coterminal side. Just like I could keep going the other direction. So I'll go negative 360 degrees, right? Negative 360, and then negative 140. So negative 500 degrees would also be a coterminal angle. So you can keep going around and around and around. There are infinitely many ways of getting to that terminal side. Okay? Questions on that so far? Okay. Another term that we will use is what we call a reference angle. So when we're looking at the sine and the cosine, we use what we call reference angle. So we don't typically, like let's say that this looks like it's about 220 degrees, okay? When we're talking about the sine and the cosine, what we're going to end up doing is making these triangles, these right triangles, to determine the length of the sides. Well, I don't make a right triangle with the full 220 degrees. I make a right triangle with the x-axis. And if I make a right triangle with the x-axis, what will this angle right here be? What's that angle going to be? What is it? 40. That angle is going to be 40 degrees. That's what we call our reference angle. The reference angle is the acute angle, right? Because we want to make sure that we're not talking about this angle, right? It's the acute angle. Remember, acute means less than 90 degrees. It's cute, right? Little angle, it's cute. Okay? It's the acute angle that the terminal side makes with the x-axis. So draw each angle and state the reference angle. So let's look at this under example 2, letter A. 150 degrees. Okay, well, this is 180 degrees, right? So let's sketch in 150 degrees. And we're not looking for an exact sketch. So I'm going to say it's right about like that maybe. Okay. That means this angle right here is 150 degrees. So what's the reference angle? 30 degrees, yes, right? It's this little angle right here. So my reference angle, we're going to call it theta, is 30 degrees. Okay. Okay, take a moment to do letter B. Draw the terminal side and then state the reference angle. Okay, so my reference angle, or my terminal side rather, right here's, if I started here, oh my goodness, why does it keep doing that? If I started here and rotated it 90, 180, 270, this would be 360, so I don't want to go quite that far. 315 is going to be like right here. Okay, so we're looking at, right, 315 degrees. So here's my reference angle. So theta is going to be what? 45 degrees, yes. Okay. Okay, negative 120. So if I start here, negative, so I'm going down the other way. So here's negative 90. And we go another 30 degrees. There's my negative 120 degrees. Okay. Negative 120 degrees. So here, what's my reference angle on this one? Good. Yes, my reference angle is going to be 60 degrees. Pretty easy, right? Okay, the last one, 140 degrees. So here's 90 degrees. Right, 180 would be here. So I'm coming up about 40 degrees. So there's our 140, which makes this 40 degrees. So my reference angle, 40 degrees. Okay? Okay, we're going to skip over the DMS for right now. We're going to come down to the radians and degrees. Okay, another way to measure angles is in radians. And this is very common, actually, to measure in radians. When we're talking about angular motion, like when we're describing the rotation of a tire, we typically use what we call radian measure instead of actual degrees. Okay. Okay. Radians have no units. One complete circular rotation is 2 pi radians. 2 pi radians. If you think about the circumference of a circle, what's the formula for the circumference of a circle? 2 pi r, right? Full circle, 2 pi r. So if your radius is 1, right? If your radius is 1, then the circumference of that circle is what? 2 pi. That's where the formula for the circumference comes from, okay? So there are 2 pi radians in a circle. How many degrees are there? 360 degrees is equal to 2 pi radians. Okay, so that means pi is equal to 180 degrees. Okay. Okay. Let's convert. I'm going to jump on down here to convert between radians and degrees. Well, let's do this part first so you get a good idea. Okay. So let's see here. We know that a full circle, full time around the circle is 2 pi. That means halfway around the circle is pi radians, right? 90 degrees is going to be pi over 2. What would 270 degrees be? 3 pi over 2. Okay. So now if I want to label negative pi over 4 radians, well, first off, I'm going this direction because it's negative, right? Negative pi over 4. How would I represent this 3 pi over 2 using negative radians?
Would it be negative pi over 2?
Yes, it would. Negative pi over 2. Excellent. Right? Because I'm going this way. Pi over 2 is 90 degrees.
So it would be half of.
So half of that. Very good. So negative pi over 4 is going to be halfway. Right? This is going to be negative pi over 4 radians. Okay, go ahead and draw your terminal side for the pi over 2 radians. Where is that going to be? Right here at the 90 degrees. Pi over 2 radians. Okay, where's the pi radians going to be? At the 180 mark. Okay. We good? Okay. Okay. To convert between them, converting from degrees to radians. Right? Degrees to radians. We're going to take our degrees and we're going to multiply by pi over 180. Take our degrees and we multiply by pi over 180. So for instance, 90 degrees, if I wanted to convert that to radians, I would multiply by pi over 180, which gives me 90 pi over 180. And 90 over 180 reduces to 1 over 2. So that's pi over 2. So 90 degrees is pi over 2 radians, right? To convert from radians to degrees, so we're going to multiply by, take our radians, 180 over pi. So it's kind of easy to remember that as long as you remember it's the 180 that we're dealing with, right? Radians often have a pi in it. Pi over 3, 2 pi, pi over 4, right? Radians have pi. So we want to multiply by something that's going to help it to end with a pi, right? Degrees do not have pi's. So we want to get rid of the pi. So we want that pi to be in the denominator to get rid of the pi that's in the radians. So that's how I remember it, okay? Okay, so if we're converting each angle from radians to degrees, okay, so here we have radians. I know it's radian. For one thing, there's no degree symbol. I want to convert it to degrees. So I want to get rid of this pi. So we're going to multiply by 180 over pi. Okay. So we're going to reduce. 6 goes into 6 once. It goes into 180 30 times. So we've got 7 times 30 is 210. The pi's are going to reduce. So that's 210 degrees. Okay. Okay, here again, we're going to multiply by 180 over pi. All right, we're going to do some reducing. All right, 3 and 180, that's going to reduce to 60. The pi's are going to reduce. So we have negative 120 degrees. Okay, we good? Okay, look at the next one. We're going to multiply by, again, we're going to degrees, so we want to get rid of that pi. So we're multiplying by 180 over pi. So let's see, the pi's will reduce 15 into 180. I'm not sure. So let's do 3. 3, that's 5, 60, okay. And then 5 goes into 60 12 times. Good. So we've got negative 8 times 12, so that's 96 degrees. Okay. Okay, let's go the other direction. Let's change these to radians. So what am I going to multiply by? Pi over 180, right. Oh, so let's see. 5 goes into 135 how many times? 5 good. If that was a 12, it would be 6. So is it 65? I don't know. Let me check my notes. Oh, of course, I don't have my notes. Okay. 5. So that's going to go 2 times 27, right? And this will be 36. If it was 10, it would be 18. Since it's 5, it's 36. Okay, so now I can reduce again. 9 goes into 27 3 times. 9 goes into 36 4 times. Okay, so we have 3 pi over 4. Okay. All right, do it again. Pi over 180. So this time I know I can reduce by 10 at least. So that's going to be 32, and that'll be 18. And then I know I can reduce by 2, so that's 16 and 9. Okay, so I get negative 16 pi over 9. Okay. And last one, we're going to multiply by pi over 180 again. So if I go 10, this will be negative 11, and this will be 18. So we've got negative 11 pi over 18. Okay. So let's do some practicing with radians. How many radians are in each angle of an equilateral triangle? Well, how many degrees are in each angle? Or each, say again? How many degrees are in each angle of an equilateral triangle? 60. Okay, so how many radians? You guys just randomly guessing numbers? Do the math. Come on, use your brain, do the math. Everybody should be doing the math. Use your brains, let's go, do it.
Pi over 3.
How do you know it's pi over 3?
Because that's what 60 times pi over 1.
There you go. Guys, don't just sit there and look at me. Do it. Do it. 60 degrees, right? How do we convert degrees to radians? Times pi over 180. That reduces to pi over 3. Okay. A minute hand of a clock travels how many radians in 15 minutes? Think it through, right? A minute and so 15 minutes. How many minutes are there in an hour? 60. So how far does it travel around the clock in 15 minutes? 1/4 around. So how many degrees does it travel? 90. And how many radians is that? Pi over 2. There you go. Okay, do number 3. The minute hand of a clock travels how many radians in 10 minutes? Do this yourself, please. In 10 minutes. Okay, how many degrees does it travel in 10 minutes? 60 degrees. And what's the radians for 60 degrees? There you go. Pi over 3. Okay. Is there another way we could have done that without going to degrees first? Right? We know that a circle has 2 pi radians. Right? 10 minutes is 1/6 of the full circle, right? Because it goes all the way around. The minute hand goes all the way around the clock in an hour. So instead of going all the way around the clock in 60 minutes, it's only going 10 minutes, which is 1/6 of that. So we divide by 6 and we get pi over 3. Okay. The minute hand travels how many radians in 5 minutes? Well, again, one full time around is 2 pi, right? 5 minutes. So how far does it travel? Not 1/6, but 1/12, right? 5 is 1/12 of 60 minutes. Does everybody understand that?
Yeah.
Right? There are 60 minutes in one full rotation around the clock. 5 minutes is 1/12 of 60, right? 5 over 60 equals 1 over 12. So that means it's traveling 1/12 of the distance around the clock. So if one full rotation is 2 pi radians, 1/12 of that is pi over 6 radians. Yes. Can you just wait a couple minutes? Is it an emergency? Okay. What is the measure of theta in radians if x equals 45? Okay, what's the radians here? What's the angle here? Right here is 45 degrees. Okay. So what's the red? What is the angle in the red? I know it's making your brain work, isn't it? 315 degrees. Okay. Now there's a couple ways of doing this. I don't want to multiply 315 times 180. I'm sorry, times pi over 180. I don't want to do that. It's too much work. Because I can easily tell you what 45 degrees is. We know that 90 degrees is what? In radians. Pi over 2. So what's 45 degrees? Pi over 4. Okay. So I know that this is pi over 4. How many radians is it all the way around the circle? 2 pi. If I subtract pi over 4 from 2 pi, what do we get? Right, this is 8 pi over 4 minus pi over 4, and that means it's 7 pi over 4. Okay. So you don't have to convert to degrees and then convert to radians, right? What's the measure in radians of theta? Okay, so what's theta? So we have 5x here, and then we have x. Well, what does x plus 5x equal? 6x, okay. And how many degrees is 6x? 180. So x is what? 30 degrees, okay. So now what's theta? 150 degrees, okay. And 150, how many radians is that? 5 pi over 6. Let's do that without converting it to degrees. How many radians would this be? This is half a circle, right? So how many radians is that? Pi. Okay, so that means x is pi over 6. So what's 5x? 5 pi over 6. Okay, everybody understand that? Takes it, your brain's going to hurt a little bit, but it's not that bad. It's not hard to understand. It just means you have to think. It's not an automatic. Okay, no homework tonight. Just make sure you study for your test.